Okay, everyone. Section 9.2 is the Pythagorean Theorem. Finally here, doing the most famous theorem in all of geometry. So it's, of course, a squared plus b squared equals c squared. And but we're going to go ahead and do a proof of it. There are literally hundreds of proofs for the Pythagorean Theorem, and this one in particular is nice because it actually has to do with sunshine. And so here is a right triangle, and we drew in an altitude to the hypotenuse of the right triangle. And so if I set up a proportion, I can find that, and I say that this is x, I can say that x is to a as a is to c, or if I'm using sunshine, a squared is equal to x times c. Sun over here, shining down this side. Likewise, I can find something for b, and so b is going to, b squared is going to be equal to, well, this piece right here, if this is x, this piece has to be c minus x. Okay, so it's going to be short shadow, c minus x, times long shadow, which is c. Now, if I take those two sides, a squared plus b squared, it's going to be equal to xc, which is right here, and plus c minus x times c. Now if I go ahead and simplify this right side, I'm going to get xc plus, distribute this, c squared minus xc. And hopefully you can see that the xc's are going to cancel out here. And so you get a squared plus b squared equals c squared. Pythagorean theorem. And so basically, whenever you have a right triangle, if you have a right triangle, then a squared plus b squared is equal to c squared. And you have to have a right triangle to use it. That's important. It does work in reverse, so the converse is true. So if a squared plus b squared equals c squared, then you will have a right triangle. If you don't have a squared plus b squared equals c squared, then you don't have a right triangle. So the question is, what do you have? So that's the other related theorems here. So if a squared plus b squared is less than c squared, so here the hypotenuse has gotten bigger, right? So if I stretch out my hypotenuse, if I stretch this out this way and stretch this out this way, hopefully you can see that you're going to end up with an obtuse triangle. And likewise, if a squared plus b squared is greater than c squared, so the c squared now is smaller, the c side is smaller, the hypotenuse is smaller, then you're going to end up with an acute triangle. Okay, so let's jump to, let's try this problem here, actually, before we jump to the back side. So if I have a rhombus, okay, and I draw in the diagonals, I know the diagonals are perpendicular to each other. That's useful because we have right triangles there. And let's say it's A, B, C, D, so let's go A, B, C, D, and I know that BD is 14. And I also know that in a rhombus, the diagonals bisect each other, right? That's one of the properties. So this is 7 and 7, and this one's going to be 48, so this AC is 48, so that means this is 24, and this is 24. So I can do 7 squared plus 24 squared equals x squared, and solve for x is going to be 25. And I could, hopefully you'll recognize this later on. This is going to be a triple, and we'll be doing a shortcut for this to get 25. But for now, do it the long way. Use your calculators. Okay, you should get x is 25. Let's flip over to the back side and let's try some of the problems on the back. So here we are on the back. Let's try some of these problems. Let's try number 3 first. Gotten home from school, you realize you forgot your key. You have a 26-foot ladder. The window is 25 feet high. So here's your house. Here's the window. This is going to be 25 feet high. And the closest you can set your ladder to the house, because maybe you have bushes there or something, is 10 feet. So this is going to be 10 feet. And you want to find out if you can use that 26-foot ladder to climb into the window right there. Okay, so let's find this length and let's see if 26 feet will work. Okay, so it's going to be 10 squared plus 25 squared is equal to c squared. C is going to be equal to, when I use my calculator, 26.9 feet. That means it's too big. This length is too big for my 26-foot ladder, and so the answer is no. I'm not going to be able to get in. Unless I jump. Don't recommend that. Okay. Number 4, classify the following triangles. So I'm going to take, I know that my hypotenuse has to be the largest side, which is 10. So I can do 6 squared plus 7 squared. If it's equal to 10 squared, then I know it's a right triangle. So the question is it equal to it? And what I'm going to find out is that, 36 plus 49 is going to be less than 100. And so I know that in this particular case, the hypotenuse is bigger, so it's going to be an obtuse triangle. I can do the same thing here. It's going to be 3 squared plus 5 squared, question mark, 10 squared. And I'm going to get an obtuse triangle again. However, this one I'm looking at is a trick problem, because guess what? You don't have an actual triangle here, because the 10 side is going to be too big. Okay, so actually no triangle. Alright, and then the last problem I want to try here is this one, or maybe not the last one, maybe I'll try the one on the bottom also, but Woodpecker, hopefully you know who that is. It has pecking a 17-foot pole, so this is 17 feet. It cracks, so it breaks off here and it falls to the ground like this. The ground is 10 meters from the pole, so this is 10, and let's call this was 17. Let's call this x here, so that really what this portion has now dropped over to here, and that portion is going to be 17 minus x. So that's what this third side is right there. So you're going to get x squared plus 10 squared is equal to the quantity 17 minus x squared. And the key here is to not take 17 minus x and square it and get 17 squared minus x squared. That is not a good way to do that. That is not true. So what you could do is you basically are going to do FOIL, so it's going to be 17 minus x times 17 minus x. So 17 squared is going to be 289 minus 34x plus x squared equals x squared plus 100. And when I go ahead and solve this thing all the way down, I'm going to get, I think you have to use the quadratic formula, which you should have learned last year. Most of the time we don't have those on tests and quizzes, quadratic formula, so don't worry about that. But x is going to end up being equal to 5.56 meters. Okay, let's do one more here. You have a rhombus, and the perimeter of the rhombus is 8√5, so let's got a lot of rhombuses or rhombi problems because of the fact that when you draw the diagonals you end up with right angles. The rhombus's perimeter is 8√5, so each of these is going to be 2√5, and one diagonal has a length of 4√2. So let's say that this shorter one has a diagonal of 4√2, which means that it's going to be half of that, or 2√2. And then to find the length of the other diagonal, I'm going to make that x. So it's going to be x squared plus 2√2 squared is equal to 2√5 squared. And so x squared is equal to plus 8 is equal to 2√5 squared, which is just 4 times 5, 20. I can do this one in this way. X squared is equal to 12, or x is equal to the square root of 12, which is the same thing as 2√3. And so x is 2√3, which means that the entire length of the diagonal is going to be both x plus x, 2x. So the length of the other diagonal must be 4√3. Okay, that's it. Go ahead and try some of the Pythagorean theorem problems.